Hi there. This video is on how to read function notation. This is the second out of 3 videos on function notation. The last one reviewed what a function was and how to identify it. This video is going to just practice how to read function notation. And then the last video will be actually solving or evaluating the functions. So, function notation is basically a mathematician's way to write an equation in a little bit of a shorter value, kind of like shorthand. So on our left here, I have an equation, and notice it has an f, a parentheses, and inside of the parentheses it says x. We read this as f of x. And basically what we're doing is we're putting the f of x here, and we're using it instead of the letter y. So instead of writing y equals 3x plus 4, we're going to write f of x equals 3x plus 4. Now, don't get hung up on the fact that this is an f. As you start working, you're going to notice we can put any kind of letter we want in front of the parentheses with the x. What these letters on the outside represent is it's just our way of telling different functions apart. So if I have 3 equations or 3 functions in one problem, each one is going to get a different letter just so we can identify it. Now the inside could also be different. The inside is based on whatever the variable in the equation is. If I had the equation y equals 4m minus 2, then we wouldn't say f of x, we would say f of m equals 4m minus 2. So this inside letter changes based on what the variable is. So this is the name, the identifier, and this is the variable being used in the problem. Now, what this really means, if we write in function notation, is this is saying the y value of the function 3x plus 4 when x is the variable. If I replace it and over here go f of 5 equals 3x plus 4, now what it's saying is it wants to know what is the value of the function 3x plus 4 when x equals 5. So basically what this is telling us is this is telling us the input into the equation. We would plug it into the equation, solve, and that'll give us our output. So this number is always just the number that's going to go into the equation for us to solve, which is what we're going to do in the third lesson. In this lesson, though, we're going to just practice reading graphs or tables to find inputs or outputs. So what I want you to think of is a function is just like a cipher. If you've ever used some sort of cipher to write a code to friends. What we have here is an alphabetic cipher. We have our letters, and we want to change what they actually represent so that other people can't decode what we're writing. Now it is a function because each letter can only represent one letter. It would be chaotic if the letter I was represented by 2 different outputs. So what this is showing us is that if I want to write the letter I, instead I would write the letter A. If I wanted to write the letter P, I would follow this up to where I see the mark, and then follow it over, and anywhere that I would want to write the letter P, instead I would write the letter H. Same thing here with Z. One last time, if I wanted a Z, I'd go up till I hit the dot, and then follow it over to my output, and I would have an R. So let's see if you can use a cipher as a function. So putting it in function notation, this whole cipher is our function f. And what we have is our inputs. So everything in the parentheses is always the input. So if I have f of a, here's my a, I'm going to go all the way up till I hit the dot, and I see that it lines up with s. So we would say when my letter is a, according to this cipher, I would actually write an s. Now f of p, oh, I did a good job. I already did both of these for us. F of p, we already said was h. And f of z, we said was r. Now with functions, we could also go backwards. Maybe we know the output, but we need to know what the original was. So this is saying what letter went into the cipher to give us an output of m. So now we're going to go backwards. We're going to go to our output of m. I'm going to follow my dotted line over to my dot, go down, and I see that the input had to be u in order to get an m. And then this one, it tells us the output was z, so we go up to z, go over to our dot, and then we follow it all the way down. And we see that in order to get a z, it had to be an h that went in. So depending on what's missing, we either start at the input and go to the output, or if we need to go backwards, we'll start at the output and then go down to the input. So let's see if we can actually write these in the right form. And if you think you got the hang of it, try one of them, and then if you get it right, go ahead and skip this section of the video. So I'm going to give you a few seconds here and see if you can decode algebra to see if you understand what we're doing or not. So let's see. I want to write algebra using my cipher, so using my output letters. So I have two A's here. So A is down here. I'm going to follow it up, and where each A is, instead I'm going to put an S. Now for L, I go to L, I go up and over, and it looks like L becomes a D. G, better put dots on this one because that's way up there. I don't want to lose my spot. Looks like G becomes a Y. E becomes a W. B, up there is a T, and R looks like it goes with J. So if we wanted to code this, we would have S, D, Y, W, T, J, S. So if you got that right, I think you know what you're doing, and you can go on to putting it on an actual number graph now. If you want a little more practice, let's go ahead and look at these ones down here and see if we can go backwards. Because now someone's written us the note and it needs to be decoded. We need to go back to see what it should have said. So I'm starting with a K. So since it's my coded, we're going to go to K. We're going to follow it over. I'm having issues with straight lines. And it looks like we have an S. Now we have a G. And G goes to O. We have two U's, so we go to U, follow it over. And that looks like it matches with two C's. W. W we already did the other way earlier. W matched with E, and J. J goes with R. So this word decoded is soccer. So that's how we use a cipher to go back and forth. Let's apply it now to a graph. Here we have our graph, and people get confused when we say, what are we talking about when we say a graph? Are we talking about this part outside? Or are we talking about all the lines? When we're talking about the graph, we are talking about the line or the coordinates that they give us on top of the coordinate grid. So when we are trying to find our pairs, we always look at the line they give us. So remember, numbers on the bottom are our inputs. That's going to be what's in parentheses. And numbers on the y-axis up here, those are our outputs. So for this first one, it says we have the function f, and notice up here it tells us this is the function f. And it tells us the input is 8. So if I go over here to 8, I look, and it looks like it touches the graph exactly at 0. So we say when the function is at 8, the y value is at 0. So let's try this one. This says, what is the value of our function f when our input is 18? So we're going to go over to 18. We follow it up. Looks like it's right here. And that coordinate pair then is 16. So we would say when the x value is 18, the y value is 16. This one is saying, what is the value of the function f when the x value or the input is 20? So let's find 20. Let's go up. And it looks like it matches with 20. So the coordinate pair would be 20, 20. Now, this is like our cipher. Now, we don't know the input, but we know what came out. So we know when it went into some equation, something happened and 12 came out. So we're going to start on the output side of 12. We're going to go backwards, so I hit that highlighted mark. It looks like it's right about there. So it looks like when x is 16, the y value is 12. And one last time with 14. 14 was the output. We hit the graph. Looks like somewhere right in here. And that's okay that it's not on a perfect line. It looks like it's maybe at about 17. So hopefully you understand now how to find an input and then use that to find the output, or go the other direction and work backwards starting at the output and going to the input. So let's try just a few more. Here it tells us the name of our function is f of x. So we know everything on this graph. That's why these are all f's. So the first one wants us to find what is the value of the function when our input, our x, is -4. So it looks like this graph is counting by ones. Always check. So here's -4. We go to where it hits the graph, and it looks like it hits the graph at 2. This one wants when the x is 0. So here is 0. And it looks like the y is also 0. The next one, our x value is 3. So 1, 2, 3. We go down. And that looks like then it's at about -1.8 or so. It's almost to -2. And the last one, -5. It looks like -5 is at 0. And then 2 going backwards. This says, what is the x value when y is 2? Now, we have to be careful here because there could be more than one answer. So what I'm going to do is I'm going to go up to 2, which is here, and I'm going to draw a line across to look for any place that it touches the graph. And notice it touches the graph in 2 places. The first one is at negative, not quite 1. So let's say negative 0.9 or 9/10. Then it also hits, we'd already done, at negative 4. So remember, it is okay to have 2 inputs with the same output. We just can't have one input with 2 outputs. And then same thing, we're going to do that with 0. Here's 0. We're going to draw a line along 0. And we get 2 answers. We get when x is 0 and when x is negative 5. Now the last thing you're going to have to be